I'm Victoria Panchenko and I'm from Ukraine. Today I'm gonna present you my project called Modern Methods of Phytoremediation of Rivers. It is well known that water is the most valuable natural resource. Unfortunately, a stage of water in most open water bodies today can be classified as polluted and dangerous to the environment. So my project aimed to explore existing methods of water purification and find a simple but effective and safe way to combat river pollution. In my opinion, the biological methods of purification based on phytoremediation is best for this purpose. This method is based on the properties of higher aquatic plants such as reeds, reed maize, which can remove contaminants from water, nutrients, heavy metals, phenols, sulfates, petroleum products, synthetic surfactants, and improve indicator of organic pollution such as biological oxidant demand and chemical oxidant demand. Phytoremediation is used in bioengineering structures, bioplater and biostands. This figure shows the typical scheme of the bioplater. Contaminated water enters the settling tank, passes through the root system of high aquatic plants, and is purified by them. To clean the water arteries, I propose to recreate phytoremediation treatment facilities based on a new type of plater, a floating bioplater of ponton type. In this design, instead of the classic soil substrate in the form of mats made of synthetic fibers, I propose to use a ponton frame to keep the shoot on the surface of reservoirs and ensure the best water circulation through the root system of high aquatic plants. The advantage of using a ponton-type floating bioplater compared to other models is that it does not require its location or shoreline. Moreover, all structures of such biotreatment facilities don't allow for use in rivers due to multiple obstacle factors such as currents, water level change, winds, waves, and others. To test the possibility of using the plant common weed, I conducted a study that is not described in any of the sources, namely whether mature and high aquatic plants can grow without soil. In only May, after digging up the rising of a plant which in above ground part of a young shoot about 30 centimeters high, I made the first solid planting of weeds, fixing its root between the stone at depths or 20 centimeters. 2 weeks later, the young shoot grew on experimental weeds without the presence of soil despite the constant change in water level and strong winds which damaged the above ground part of the weed, and its rhizome began to form periphyton. To prevent the action of the above negative factors, wind change and water level, a ponton-type bioplater was created. The initial model consists of a wooden frame with an area of 2 square meters and 2 layers of metal mesh with where to keep the roots on the plant. At a certain depth, planting materials was taken on the banks of the Dnieper. The rhizome was placed between the layers of the mat, and the weeds were right together to support each other. The created structure was fixed and placed in the river next to the natural reeds. A month later, a survey of a studied object revealed that about 70% of the reeds survived. It just grew by 50–80 centimeters and young shoots appeared. In the underwater part of the bioplater, the root system developed very well and periphyton was formed. But as the green mass of weight increased, the wooden structure began to sink. Therefore, the following year, the bioplater model was improved. The wooden frame was replaced with a pipe one. In addition to its reed maize was planted. In autumn, the plants took root and developed well. Thus, the structure was not damaged by animals, waves, or wind, and withstood the growth of green mass. Thus, my experiment proved that the proposed design of the floating biplater of the Bunsen type can be used in open water bodies. The design of the industrial motor of the floating biplater of Bunsen type is checked to employ calculation, as it's a very massive design. The paper calculates the parameters of a rectangular model with an area of 10,000 square meters, consisting of four axially floors holding a frame of I-beams fastened with reinforcement and covered with a net for mounting high-aquatic plants. Located along the perimeters of the floats contain several ballast chambers that can be filled with water if necessary to control the level of immersion of the structure and ensure its buoyancy. The next step was calculated and presented in the form of a table of loads to be held by the structure. Also, the maximum possible weight gain of phytomass, 50 kg per square meter, is taken into account. The total mass of the load on the floats of the plater area of 10,000 meters will be 750 tons. After calculating the load, we find the parameters of the floats need to keep such a structure on the water. Using the basic laws of physics, the parameters of the floats were selected to that they could hold the required weight. For convenience, the results and the course of calculation are listed in the table. The results of the calculation show that the base of the floating biplater of fountain type should consist of pipes with diameter of 1 and 5 meters and supporting pipe 1 and 20 meters. The design will be able to withstand a load of 750 tons, the main pyro with a phytomass 500 tons. If the regular amount of phytomass for its further use, you can reduce the cost of construction. According to our calculation, the maximum cost will be only 270,000 years. So, in conclusion, I want to say that my project I researched the exciting methods of water purification and propose the modern methods of combating river water pollution with the help of the floating biplater of Bunsen type. This design is only fairly low cost and efficient. Thanks you for watching.